Good morning, sir.
Good morning, all.
Sir, can you confirm that tomorrow do we have a holiday because of Ganesh Chaturthi?
Institute didn't announce a holiday tomorrow.
Okay.
If they announce, generally before the beginning of the year, they give the holiday list. So in case there is any change, I shall let you know by ERP mail. Okay. But
Okay, sir.
as of today, there is no holiday tomorrow.
Okay, sir.
But in past, we never had a holiday on Ganesh Chaturthi, you know.
Oh,
So my guess most likely tomorrow is open. But in case it is closed, I shall mail you all.
perfect, sir.
I know the southern part and western part of India, it is one of the biggest festival,
Festivals. Yes, sir.
but not this part of the country.
Okay, sir.
So I shall keep you posted, okay?
Okay, sir.
Okay. I wish all of you a very happy Ganesh Chaturthi.
Thank you, sir, and same to you.
Thank you. How many of you have joined now? The class, can you see that? Because once I go for the full screen, I can't see it.
50.
The
50, okay.
51.
Okay.
51. One is you.
When we come to 70, please let me know. We have 76 strength.
Okay, sir.
All of you have an access to textbooks. Please procure a textbook, okay? They are not expensive. But on PDF, if you read it, you will never learn it that well. When you have a physical book, you read it, you underline it, you put a note at the margin. And that feeling is very different than reading a PDF. How many have joined so far?
55.
55, sir.
55. Is Javalkar Gauri Vignesh present?
Present, sir.
You?
Yeah.
Okay. What is your first name?
My first name is Gauri Vignesh, sir.
Gauri Vignesh. This is how you go by, right?
Yeah, you can call me Vignesh or Gauri Vignesh, anything, sir. No issues in that.
Anything. Okay.
Yes, sir.
Well, thank you very much, Gauri Vignesh. On behalf of your class, you wished me Happy Teachers' Day. Very thoughtful and writing. I read it this morning just before getting online, and I'm deeply, deeply touched by all of your nice and kind words. Thank you so very much. So this is the second time we are having a class online and we can't celebrate the Teachers' Day. I miss it, but I thank you all. And Gauri has done it on behalf of everybody in the class. So I express my sincere thanks to all
Sir,
of you, and
actually,
I am
it
deeply
was
touched
done.
by your thoughts. Please tell me.
Sir, actually, it was done by every one of us. Gauri,
Oh yes,
and only
we
Gauri
have
was.
typed it. I know that everyone,
And if you
because
could, the poster was made by only one, and that's Aditi. If you thank her, it would be really good, sir.
huh?
The poster.
Ah,
It was made by Aditi sir. So if you acknowledge her, it would be really good, sir.
full name?
Aditi Pasi.
Aditya.
Aditi.
Aditi Pasi.
Aditi, what surname?
Pasi,
Sir,
if I'm
Aditi
pronouncing it right.
Basi.
Aditi, are you present?
Yes, sir.
Oh, it's fantastic. I didn't know that. I thought somebody copied and pasted that sketch somewhere, but it is really, really nice.
Thank you, sir.
So, Gauri, on behalf of everybody, posted it. So, I express my sincere thanks and love and affection for all of you. You are younger than my son, and I look at you as my own son and daughters. You are my children. Not just students, you are my children, and I am deeply touched to hear from all of you. So, Aditi, what type of painting do you do?
Sir, normal painting, any kind of painting I do.
Sketches, portraits?
Yes, sir.
Okay. So, generally, every class or almost every year, I find somebody who does fantastic portrait, and I request that to make a portrait for me, and I keep it in my office framed. And I started my teaching career in IIT Madras in 1996 and left in 97 and joined IIT Kharagpur. And so from 96 onwards, from time to time, some students do a sketch of mine, and I keep it on my in my office or my personal room there in the department. So since 1996 I have. So when you find time, please give me a sketch of mine done by you and sign your name.
Yes, sir. Sure, sir.
Okay, that will be a wonderful treat. So I'm asking a presence from you. Or anyone else in your class is a good artist, please do it. I'll frame each one of your paintings, drawings, sketches, and keep it in my office. And hopefully,
I
we'll,
do, sir.
we'll physically meet on campus. Let's hope the third wave does not come and we can have physical meeting, we can sit down, discuss, chat, laugh. Okay, because this is terrible. I enjoy roll calling, do you know, because that way I can see your face, I can match your name with that, and your memory will always be etched in my heart forever. I
Actually, sir, we
really
could have
miss that.
planned something more if it was an offline sem, but in an online sem, we couldn't do much.
Oh, that's fine. We'll do it whenever you wish.
Yes, sir. Eagerly waiting for it.
Ah, probably I am more eager for that than you guys,
Yes, sir.
because I have 5.5 years left before I retire. So I am missing this 2 years gone from my life, and I truly miss you guys. Without you, it makes no sense to be in IIT Kharagpur. The campus, you know, almost 16,000 students are present. There is a vibrant campus. Everything was there. But now, when it is all silent, hardly anybody is there. Terrible, terrible. And I could never imagine something like this will come to. I have to see something like this in my lifetime. But only one good thing happened. Do you know what? Are you there?
Yes, sir.
Yes, sir, we are listening.
So many hostels, 25 plus hostels.
Yes,
So
sir.
you have more than 1,000 four-legged friends in the hostels. Means the stray dogs. I don't like to call them dog. They are fantastic living creatures. So when the mess got closed, they didn't have food to survive on. So some faculty advisor, faculty colleagues got together, their family members collected subscription and started making food for them and feeding them every day so that they can survive. But since the lockdown, one after another, 8 of those came from the hostels to my home. So I live on a old bungalow when IIT was built. At that time, those for American professors, they built those bungalows approximately on 1 acre land. So plenty of space and lawn there. They can play and stay there. So now I have 8 of those. And these 8 gave me fantastic company in last year and a half. And hopefully they will not go back when you return to hostel. They will stay with me. I hope so. Then I will terribly miss them. Okay, any question from your side for me? Anybody?
Sir, no question as such, but it would be great if the exam on 10th, on which we, on the day which we have Ganesh Chaturthi, we celebrate a lot here. So if it is postponed or something delayed, it would be great help for all of us, because all of us celebrate it in a great manner. There'll be puja and everything in home, so that's the reason. If it is possible, obviously.
Okay, done.
Thank you so much, sir.
You're
Thank
always
you, sir.
welcome.
Thank you.
Then give me some time on one weekend to have, and don't worry about the exam. I never ever trick my students. I just want to find out how much you have understood. That's all. I never give a tricky question as such. And that's the reason I prefer to do Viva, because many time people say the students, my students complain, some people did not follow the fair way of writing exam, blah, blah, blah. And to me, all students are innocent, but no student should have doubt in their mind that somebody adopted unfair means. So if I do Viva, I can eliminate that chance. And in Viva, if I ask a question which you do not know the answer, I can ask another question. If you do not know the answer, I can ask another question until you give me an answer. So that way, I can evaluate you better, and in writing, you have the only one scope. If you do not write correctly, then you lose the mark. So uh, don't feel bad that Viva will be tougher. Not really. It will be a lot easier than written test. Okay.
Yes, sir. It's much better now.
Don't worry about it. So on Ganesh Chaturthi Friday, there will be no class. So hopefully all of you will enjoy, and send me some photos of your celebration.
Yes, sir. Definitely, sir. Thank you so much, sir. Thank you so much.
So let's start with the class. The last class I showed you the crystal structure of buckyball, carbon nanotubes, and so on. So same carbon as a graphite hexagonal structure which you use for aluminum lithium alloy battery. The same carbon, at least one or two of you are wearing a diamond ring. Same carbon has a different structure, diamond cubic structure. If somebody is using this kajal, you know that in the eye, the ladies wear those things. If it is homemade, then that carbon, when you burn ghee and you make this carbon there and your this kajal pan, and then you put it underneath your eye, that is an amorphous carbon. The buckyball is a carbon. Carbon nanotube is a carbon. So same carbon atom can have different configurations of arrangement. So this thing I'll not go your polymer structure. Now, to summarize what I have said, 7 crystal systems, and from there I can make 7 more, total 14 Bravais lattices. And lattice constants means the length of along the each axis and the angle between them, the 6 parameters. Now we are going to index the direction and the plane. First of all, say we are considering a cubic unit cell. Choose any corner of this cube as origin. Let's see this origin 0, 0, 0. This is my x-axis. Oh, sorry, I have to go to the pointer. This is my x-axis. This is my y-axis. This is my z-axis. By the way, before I forget, all of you attended lab class on Tuesday?
Yes, sir.
Yes, sir.
Okay. So Professor Tapus Bandyopadhyay will inform you the lab class day and time next week. Okay.
So it
And
was on Monday actually. Tuesday, yesterday we didn't have a lab class.
but he said they will be reschedule the class, right? Tuesday or something because some intake. Anyway, please keep an eye on your email, ERP mail. He will inform you about the new date and time for the lab
So,
class.
so it was told that the two labs will be interchanged, the lab timings.
Yes, but just for confirmation, I am not sure yet because I will continue my second half of that lecture of optical microscopy. Were you able to find out something I those websites I asked you to check?
No, actually.
Please do so, huh?
Yeah,
All the
yes.
slides, PPTs were taken from those websites.
Yes, sir,
Yes,
sure.
we
When
are not yet sure
when
about
those are
the.
in their websites, actually those companies send me separately, but those are all available in the website.
Actually, sir, we are
And
not
those
yet
Metal
confirmed
Handbook
about
volume
the.
9 and 10, you can read those. Vanderbilt's chapter, one chapter in that book is excellent. Any question?
Yeah, I was saying, sir, we are not yet confirmed about the class interchange of Monday and Tuesday. So it's not confirmed yet. We didn't get any
But
official mail that the class
they
is
will
interchanged.
confirm it. So
Yeah.
I'm saying that please keep an eye on your mail, either your regular email or through ERP
Yeah.
mail.
Yes, sir.
Because I do not know yet. I'm yet to find out when it will be fixed because other teachers involved, other section, postgraduate students are involved, and time slots availability is also a question. Okay?
Yes, sir.
Because please be patient at the beginning because we go through hell lot of difficulties because of this online mode. Okay?
Yes, sir.
You see that last Monday when I was taking classes, I was taking classes from my chamber or I call my office in metallurgy department, and I had a lot of difficulties in that Microsoft Teams I was using and Windows 7 there. I did not get this laser pointer there. I don't know why. Then I found out some system laser pointer is absent, only highlighter and a pen. So,
It's real difficult. Yes,
and
sir.
the teacher will also try their best. The lab experiment they will do by videos, send you the data. You can prepare the report. This is the best we can do under this circumstance. Please don't feel disheartened. We are going through the most horrible time in our life, everybody's life. And we have to make the best out of that situation.
So
So what,
chances,
please tell me.
what are the chances that next semester will be offline?
I have no idea. Honestly, I don't think anybody has any idea. Let's pray to God that third wave will not come
Yes, sir.
because what a disaster for the entire world, you see. The problem is people are taking vaccine and they think that nothing will touch them and we stop wearing masks, stop sanitizing their hands, they are not maintaining safe distances. What will happen? Is the fault is ours. The government cannot control our behavior. We can only control our behavior. You see, when the lockdown started, again, second phase in mid-March, I did not go out of the campus, IIT Kharagpur campus. Only this weekend, after 6 months, I went to my hometown, my home in Howrah, just went there and spent the Saturday night and Sunday I returned. Did not go out anywhere. You will be surprised to know as soon as first time in 6 months I left IIT Kharagpur campus. And outside, as if nothing happened. Hardly anybody wearing mask. They don't care. And this is how this disease is spreading. So let's
Yes.
keep our finger crossed. Hopefully third wave will not come and you will be able to return to campus at the earliest. I know it is terrible. 3 semesters passed by, you have not seen IIT Kharagpur campus, which is truly beautiful. It's a fantastic campus. And
Yes.
those who love nature, you will really like Kharagpur. Please tell me what you're saying.
Nothing, sir. Yeah, I was just agreeing. I was saying yes, sir.
Yeah, because I have never been to Kanpur, but other IITs I visited. Uh, to me, IIT Kharagpur campus is the most beautiful one. And of course, IIT Guwahati is also very nice because it's on hills, lakes, and you can see those things. But that's just not that many students as we have. So ours is 2,400 acres land. So let's hope we can come back and have a physical semester in spring 2022. So what I was saying, the origin, any point in this cube I can fix as the origin 0, 0, 0. This is the x direction, this is the y direction, this is the z direction. So this point, coordinate of this point will be this point. 1 unit along the x direction, 0 unit along the y direction, and 0 unit along the vertical direction. So the coordinate will be 1, 0, 0. Similarly, the coordinate of this point will be 0 unit in the x direction, 1 unit in the y direction, 0 unit in the z direction. So it will be 0, 1, 0. Similarly, this point will be 0, 0, 1. This point diagonally opposite to 0, 0, 0 point. What will be the coordinate? 1 unit you have to come along x, another unit along y, and vertical direction and one more unit. So 1, 1, 1 will be the coordinate of this system. Okay. So this is how you put coordinate to each point in a lattice. If I see this picture is from Shackleford, if this is 0, 0, 0, this will be 1, 0, 0, this will be 0, 1, 0, this will be 0, 0, 1. You see, this is not cube, but along each direction you say this length may be different than this length, but you say 1 unit in the A, 1 unit in the B, 1 unit in the C. So that's the way. Even A not equals to B not equals to C, we call this point as 1, 1, 1. So don't mix it up. If A not equals to B, if B not equals to C, still this point is 1, 1, 1, because you consider this is 1 unit in the x direction, this is 1 unit in the y direction, this is 1 unit in the z direction. So this corner point will be 1, 1, 1. Now this point will be what? 1 unit in the x direction, 1 unit in the y direction, and 1 unit plus another unit, 2 unit total in the z direction. So this will be 1, 1, 2 coordinates. Now this point will be 1, 2, 1, 1 unit in the x direction, 2 units in the y direction, and 1 unit in the z direction. So 1, 2, 1. This point in the center of this unit cell, half unit in the x direction, half unit in the y direction, half unit in the vertical direction, z direction, so half, half, half. So similarly, this point will be half, half, and 0. Now, you say I have to quantify, but I have to mathematically express an unit cell and how the atoms are located there. First, if I have to find out a crystallographic direction, I have to index those directions. Direction means this direction. Along this, along this, along that, along the body diagonal, along the face diagonal. What is the, how do I quantify this direction? So these directions, each of them are vectors. They have a magnitude and they have a direction. First of all, if I want to find out a direction from the origin to this opposite corner, means along the body diagonal, what will be the direction, is vector. First, life becomes simple if that direction goes through the origin. So the end point coordinate minus the origin, you get first. So this is 1, 1, 1. So the vector will be 1 minus 0, then 1 minus 0, then 1 minus 0, third one 1 minus 0. So because it is 1, 1, 1 and this is 0, 0, 0. So end point coordinate minus the origin. So 1 minus 0, 1 minus 0 and 1 minus 0. What happens? The result is 1, 1, 1. And you don't put a comma in between. Do not make this mistake. And put that thing in a third bracket. So this body diagonal index will be, crystallographic index will be, first it will be 1 minus 0. Don't put a comma. 1 minus 0. 1 minus 0. The result will be 1, 1, 1. And it will be in square bracket. So this direction from this origin to this opposite point towards this direction, there will be 1, 1, 1. So what I wrote here, determine the coordinates of vector tail, that is point 1, xy, x1, y1, z1. Vector tail means this origin. And the vector head means this is the point. If this is x2, y2, z2, then what you do? You find out x2 minus x1 divided by this length a, y2 minus y1 divided by length b, z2 minus z1 divided by length c. In this case, a, b, c are all equal. If you get an integer, fine. If you do not get an integer, a fraction, so you can multiply by certain number all these three so that you get an integer and put them in a square bracket. Put them in a square bracket. This is the square bracket. Okay, any question? Hello?
No, sir.
Okay. Now, how do I determine the crystallography direction, this blue one? This point coordinate is what? 1 unit in the x direction, 0 unit in the y direction, and half unit in the z direction. So what happened? An origin is 0, 0, 0. So 1 minus 0, 0 minus 0, half minus 0. So it becomes in square bracket this vector point 2, it becomes 1, 0 and half. But I said you cannot write a fraction. It has to be an integer, smallest possible integer. And if I multiply by 4, it will be what? 4, 0, 2. That is definitely not the smallest possible integer. If I multiply by 2, it becomes 2, 0, 2 into half, 1. So this is the smallest possible integer, and this crystallographic direction, this one, will be 2, 0, 1 without comma in a square bracket. Can anyone tell me, like this PPTs I'm showing it, okay? and I'm writing this thing and highlighting it with my mouse. But can I do the same thing? I'm projecting from my computer. In a desktop I'm doing because I have a better camera there than laptop. But can I connect my iPad to it just for this annotation, writing, marking? Nothing else, because certain your pads are available where just for annotation purpose, but not so good. But I will not project it from the iPad, these slides, PPTs. It will be from my desktop, but iPad I shall use it only for writing. So there I can see in iPad what I am writing, it will be projected here or vice versa. If you know, any one of you know how to do that, please let me know. Without showing slides from the iPad. Now, certain crystallographic direction. So this direction, this red color, starting from point 1, ending on point 2. Origin is here. This is my origin. It is not passing through the origin. What do? Easier thing is to do, draw a line, a vector parallel to this vector through my origin and see where the end point is. So the coordinate of the end point -0, will give you that vector. So if vector does not pass through the origin, draw a parallel vector which is passing through the origin. Why it can be done? Remember the symmetry I talked about. Definition of a point lattice. You stand at any point of the lattice and look at a particular direction, whatever view you will get. You can move to randomly at any other point and look at the same direction, you will get the same view. So because of this, you will be able to draw a vector parallel to this given vector, and where it ends, that coordinate -0, will give you the correct answer. Or if you know the coordinates of point 2 and point 1, like this, you can subtract what you got -2 half 1. Multiply by 2, because you have to make a smallest possible integer. So it becomes -4, 1, 2. In square bracket, you write this one, no comma, absolutely no comma. This comma should have been avoided while writing it. It's from Callister's book. This comma should be avoided. Okay, give a space so people will understand these are different. Remove this comma. So you got -4, 1, 2. In crystallography, we don't write -4 like this. We write bar symbol above the integer. Above integer what? Which is negative. So -4 we write as bar 4, 1, 2, not 4 bar. Bar will be pronounced before that integer, which is negative. So -4 becomes bar 4, and in square bracket without comma. So this is the indices of this direction. So never set 4 bar, always bar 4. Bar will be pronounced before the negative integer. And this is the negative index. What is the most favorite candy bar or chocolates of a crystallographer? Anybody?
A bar.
Huh?
A bar.
No? Try again. Anybody?
Sir, Milky Bar.
No? Coming closer and closer.
Dairy Milk, sir.
Huh?
Dairy Milk, sir. It is like a crystal.
No. Guess.
James.
Nope. It is called bar 1. There is a candy bar. You can go to a chocolate shop and find out. This bar 1 is a chocolate. It's still available. Okay. Now, you have another thing, which I'll show in next slide. If the directions are of same nature and related by symmetry, instead of a square bracket, we say angular bracket, UVW, means you can say a family of direction belonging to this type. I will explain to you later on. This is my origin. This direction is the negative direction. 1 unit, when this coordinate will be what? 1 unit in the x, 1 unit in the y, 1 unit in the minus z direction. So the direction will be 1 minus 0, 1 minus 0, minus 1 minus 0. So 1, 1, bar 1 in a square bracket. So this will be 1, 1, 1. You see, this is 1, 1, 1 because they are parallel and related by symmetry. This is also 1, 1, 1. This is also 1, 1, 1 because all these directions are parallel to each other. They are passing through one of those lattice points. And a parallel direction can pass through the same origin also. This is passing through origin. This is parallel to that direction. This is also parallel to that direction. This is parallel to that direction. You see, this was my origin. I can shift my origin here. I can shift my origin here. I can shift my origin here. XYZ direction remains unchanged. But I can shift the origin because the definition of point group suggests that if I move from one point to another point, I get the same view. In this figure, this is my origin. This is x direction, this is y direction, this is z direction. All these 1, 1, 1 type directions are shown here. This is bar 1, 1, bar 1. This is 1, 1, bar 1. Now this one, it is in Shackelford book, this figure is. Please try to determine on your own how you end up with these indices. This is bar 1, bar 1, bar 1. This is 1, bar 1, bar 1. This is 1, bar 1, 1. This is bar 1, bar 1, 1. This is 1, 1, 1. Now tell me, what is the relationship between all these directions? Is there any relationship? Are they related to each other somehow?
Sir, all are body diagonals.
All are
Body diagonals.
Okay, very good. Anything else?
Sir, all of them are inclined at 45 degrees from the plane.
Correct. Anything else?
All these are permutation.
You see here, this is my 1, 1, 1. What is this? Bar 1, bar 1, bar 1.
Opposite.
This is just opposite to it. Negative sign. This is bar 1, 1, bar 1. Negative of that will be 1, bar 1, 1. This is 1, bar 1, bar 1. Negative of that will be, this is bar 1 and this will become positive 1, 1. Now, any idea? And all these directions are called directions of a form. They are related to each other and in a triangular bracket we write. And they call family of direction or directions of the same type. Anything else striking your mind now looking at this? This for cubic system it is drawn.
They are related by permutation.
Huh?
So
They are all symmetrically related. You see, if I draw along this axis, two opposite face diagonals I join. This is my axis. And I have a rotational symmetry. I rotate it fourfold. four-fold rotational symmetry. This one becomes one bar one becomes after one fold rotation, this one, your this direction, what I'm saying, 111, we rotate, this become, so every time I rotate, all these directions remain identical. There's absolutely no change. So the symmetry I talked about so far, you can see this symmetry. The mirror plane, this is the mirror plane of the center. If you take a three-fold rotational axis along the body diagram, if you take a two-fold rotational axis through two A centers, you will see the symmetry. And later on you will study. So many properties of materials are dependent on this crystallographic direction. Remember at the beginning I showed you a picture of a beverage can, aluminum can, and an aluminum foil which is used to wrap food. They are from a type of aluminum, almost pure aluminum, little bit of tiny bit of aluminum elements are there. Same aluminum, one is made for one is used for can, and same aluminum is used for foil. So remember, if you fill the beverage in a can and it crumbles like the aluminum foil, will you be able to store your beverage in that aluminum can?
No, sir.
No. Now you made a sandwich. You want to wrap it up with the aluminum foil and put it in your tiffin box or a Ziploc bag and take it to your hostel room, eat it, or you go to any restaurant like Subway and others, fast food place, they wrapped it up a sandwich in aluminum foil or paper they give, but they can also wrap it up in aluminum foil and bring it to your room. But as soon as you wrap it with aluminum foil, it springs out, means it becomes a flat again. Can you use as an aluminum foil? No, you cannot. But same composition, one behaves like a aluminum can, the other becomes like a foil. How do you achieve that? When you make this foil materials or can materials, generally from 7 mm thickness aluminum plate, about 22 different ways you roll it down in a rolling mill. Rolling mill means just like you roll a chapati paratha, similar type of thing, two rolls moves through which you pass this thing. It is easy to say, but if you find out in the net, you will see a lot of videos how it is done. So 28 to 24 stages it is rolled down, and in between they do special heat treatment to make sure the grains you are developing, the cells and the grains I mentioned in previous classes. We don't call cell, we call grains. The grains will be oriented along particular crystallographic direction or axis, and the planes will be parallel crystallography to the top surface of this thin foil. If the grains are oriented that way, then you get a property just like can, or oriented in another way, you get the property like an aluminum foil, which you can wrap easily, it will not spring out. The same aluminum, during processing, you orient the grains in a particular direction, and the grain surfaces will be parallel to the top surface of the foil or the can, parallel to a particular crystallographic plane, which I will teach you tomorrow. Then and only then you get completely opposite properties, the properties of a can and the properties of a foil. One springs back, can, the other does not spring back, that is foil, from same aluminum. By orienting the grains of that aluminum along the particular direction and parallel to particular crystallographic plane, you get two opposite properties as per your requirement. So you see why you need to study crystallography. You see, if you have a good transformer, the humming noise is less. It becomes less hot. more energy efficient. That because you develop the texture in that soft iron core. Texture means the preferred orientation of the grain, so that the eddy current losses will be the least. So this is how. There are so many other properties you will learn through the course of this lecture. Depends upon this crystallographic plane and direction. Any question? No? Now, how do we index a plane? Yes? Question, please. Hello? Okay. The crystal, man, how do you index a plane? Generally, indexing of plane is called Miller indices. Miller indices. Miller indices. What do I do first? The plane makes intercept along this X, Y, and Z crystal axis. If it doesn't make intercepts, it will be parallel to that direction. So whatever intercepts it makes, including parallel to it, you take the reciprocal of that. That intercept you get, you take the reciprocal of that. Why reciprocal? I shall explain shortly. And if you get fractions, multiply with the smallest possible multiply with a digit so that it becomes the smallest possible whole number, integers. So the algorithm is this: read off the intercepts of a plane with axis in terms of A, B, C. Then you take the reciprocals of the intercepts. Reciprocals of the intercept. This is very important. Now reduce it to the smallest integer. Smallest is important, an integer is important. Don't take a fraction. And then enclose in round bracket or first bracket or parenthesis, whatever terminology you use. Parenthesis, round bracket, first bracket, everything without comma. That is the indices of a plane. UVW is used for direction. Symbol. For plane you write HKL, and instead of UVW you put a number, in place of HKL you put a number. Now this is an example. This is my origin, x-axis, y-axis, and z-axis. This blue hatch plane intercepts the x-axis at 1 unit length, y-axis in 1 unit length, and it is parallel to, parallel means it is not intercepting, to the vertical axis. So what will be the intercepts? Sorry, I will do infinity. 1 unit along the x, 1 unit along the y, and parallel to the z direction, to infinity. I said do the reciprocal of the fractional intercepts. This is 1, make it 1 by 1. And this is 1, take the reciprocal of that, it's 1 by 1. This is 1, take the reciprocal of that, is by 1 by 1. Now infinity is there, so it will be reciprocal of 1 by infinity. That makes 0. The reason we choose reciprocal, because parallel plane will give infinity. In math, you cannot do sums with the infinity, but you can handle 0 easily. So that's the reason. First we do the intercept, second we do the reciprocal of the intercept, so that infinity symbol is done. and we reduce smallest possible integer. 110 is already a smallest possible integer. You don't need any further reduction. And write in the square bracket without, in round bracket or parenthesis, without comma. This is the Miller indices of this diagonal plane. Yeah, blue color. Now this is an example, this red color plane. What will be its indices? It intercepts the x-axis along half the length. It is parallel to the y-axis. It is parallel to the z-axis. So intercepts will be half, parallel to b infinity, parallel to c infinity. Now you take the reciprocal of that. When I take reciprocal, it is 1 by half, 1 by infinity, 1 by infinity. And Miller indices will be in round bracket or parenthesis 200. I can also write as 100 because it is symmetric to the 100 plane. This is an example of this triangular plane. It intersects the x-axis in half the length, y at 1 length, and vertical axis on the 3/4. So intercepts will be half, 1, 3/4. Reciprocal of that intercepts will be 1 by half, 1 by 1, 1 by 3/4. So that becomes 2, 1, 4/3. I have to make an integer. I cannot use fraction in these indices. So I multiplied by 3, so it becomes 6, 3, 4. So denominator 3 is gone if I multiply it by 3. So I get the plane indices in parenthesis or first bracket or round bracket 6, 3, 4. This is the Miller indices of this plane. This is where I end here. I shall continue from this slide onwards tomorrow. If you have any question, we can answer for another couple of minutes we have.
Sir,
Yes.
so in the initial classes you told us about shape memory alloys. So
Yes.
does it have to do with crystallographic direction?
When I teach martensitic transformation after the middle of the semester, please ask me that question. Don't forget, huh? I'll answer that question.
Okay, sir.
Sir, if the plane passes through origin, then